friends, in this video I'm going to explain how to prove 2 plus root 7 is irrational. So as per the previous problem where we proved root 5 is irrational, here also we will consider exactly in the opposite of the what is mentioned in the question. So here we will assume let root 2 plus root 7 is rational. So here also, like the previous proof, we will assume just opposite of it, that let 2 plus root 7 is rational, and its proof is very small, not at all lengthy like the previous one, because here we will be using one of the property which we have studied in class 9. I hope you remember. That property is square root of any prime number is irrational, if you remember, because many of the students simply forget this property, very important property, which can be used in proving this problem in a very short way, in a very simple way. So I am just recalling that property which will be helpful in proof of this. So here we have assumed 2 plus root 7 is rational. So if something is rational, of course that thing can be written as a by b, where a and b are co-prime. That means there is no common factor between a and b, isn't it? Now what we will do, we will only leave this square root term at one side and bring all other terms to the other side. So here root 7 remains here only, a upon b minus 2. Now find out the LCM. It is b, a minus 2b. Here we know a and b are nothing but some integers. So when this is an integer, this is an integer, and that means when we see in a wholesome way, it is nothing but a ratio of some m by n. If I simply replace this by n and this by m, it is a ratio of m by n. That means in a by b form, if we compare, isn't it? It can be written in the ratio m by n. It can be written in the ratio a by b, and any number which can be written in the form of a by b, where b is not equal to 0 and a and b are co-prime, such numbers are called rational numbers, isn't it? But here what we see on the left hand side, root 7, what is 7? 7 is a prime number, and what we are having, square root of a prime number, and which says that as per the property given in class 9, which we have already studied, that states that square root of any prime number, square root of any prime number is irrational. Very, very important property of class 9, which generally everyone forgets. I mean, students mainly, they forget this property, which can be written over here. Square root of any prime number is irrational, but here we get root 7 as rational, which is a contradiction. So we will write that contradiction over here, which is a contradiction. What is a contradiction? Our assumption that root 7 is rational and the fact that root 7 is irrational. These two contradiction we came across. So we will write that only, which is a contradiction. Therefore, our assumption is wrong. You can even write absurd. Therefore, our assumption is wrong, which hence 2 plus root 7 is not rational but irrational. Hence 2 plus root 7 is irrational. Simply you can write in this way. I hope the proof is clear to everyone, and I believe this was a bit smaller compared to the previous one, and very easy to understand. We simply assumed 2 plus root 7 is rational, and if it is rational, it can be written in the form of a by b, and just leave the root terms at one side and shift all other terms to the right hand side. And what we got? Ratio of integers. That means root 7 can be written in the form of a by b. That means root 7 should be a rational number. No. Why no? Because in 9th standard we have already studied that square root of any, you can write we know that. In this way you can write we know that square root of any prime number is irrational. So this causes a contradiction to our assumption. Therefore our assumption is wrong. Our assumption is wrong. Hence 2 plus root 7 is irrational. This is how we have to prove this problem. I hope this type of questions can now be proved very easily, be it 3 plus root 5, be it 1 plus root 11, be it 5 plus root 3, whatsoever type of number you get, the proof is very, very similar. In the same manner you have to prove any such question. Thank you.